Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on digital transceiver. Okay, so earlier on the part 1 and also the part 2 series discussion, I mainly have discussed the transmission portion of the digital transceiver. This video, I will focus on the receiving end of the digital transceiver. This will be the part 3 series discussion on digital transceiver. So guys, if you're keen to know more about digital transceiver, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on digital transceiver. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are also welcome to ask me your question through the comment. Okay, before I continue, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. This is what I have discussed earlier on. Okay, so as I mentioned that this actually shows the general block diagram of a digital transceiver. On the part 1 and part 2 series discussion, I have discussed all these blocks. Okay, so this video, I will focus on the receiving end. Okay, so basically, for the receiving end, they actually represent a digital back end, okay, which means that I actually receive a digital back end that actually receive digital signal, and we may need to convert back to analog signal, but may not be necessary in an analog signal. It can be still remain in a digital signal. But in short, okay, so we are going to focus the receiving end of the digital transceiver. Let's focus on the RF for a start. Okay, so under this RF component, we have the down converter. We also have the demodulator. Okay, so what is actually a down converter? Okay, a down converter is simply used to shift the frequency of an incoming signal from a higher frequency to a lower frequency. So in short, down converter simply convert the frequency from high to low. Okay, why we will need to do this? Okay, so down conversion is actually very common in communication system, especially in high frequency or even microwave application. Okay, so the primary role why we need to have this down converter is simply to make signal easier to process, analyze, or amplify by shifting them to a more manageable frequency range. I guess you know that in order to buy any RF component high frequency, they actually cost more. Okay, why? This is because it is much challenging to process, to analyze, or maybe to amplify the signal. So hence, in order to reduce the cost, so the simplest way is to shift the high frequency to low frequency. So basically this is what it means. So this is critical for processing high frequency signal, since lower frequency are typically easier to handle in most analog and digital system. So what does a down converter actually mainly consist? Firstly, it will have a mixer. I guess you know the key purpose of a mixer. For a receiver, they actually combine the high frequency input signal. So basically at the input of the mixer is actually a frequency that typically is having a higher frequency. And then we also have this LO, local oscillator. So basically they will be producing two output frequency at the output of the mixer. First will be the sum, which is the sum of the RF and also the LO. The other one is the different, which is the different, either RF minus LO or LO minus RF. So basically this is what is over here. So next we have this filter. Remember, we always want to extract out the different. So either RF minus LO or LO minus RF. We just need to extract that frequency. So therefore the filter actually will select the lower frequency, basically will be the different as I mentioned here, and the filter role is simply filter up and pick up the desired so-called signal, which is the different of the original frequency. The rest they will filter away. So I guess I have also explained on the LO. So basically it's a very precise oscillator that is helped to generate the required frequency, so as to combine with the input signal in the mixer, so that we are able to achieve the two output frequency at the output. Okay, what is the role of the demodulator? Okay, the primary function of the demodulator is to simply extract up the original information bearing signal. Okay, so basically in short, okay, let's say we do some modulation. Okay, we have the modulating signal, we also have the carrier, and then we actually combine these two into a modulated signal. So basically the key idea of this demodulator is to extract the original signal, okay, which is the modulating signal. Okay, for example, at the modulating signal, it can be in a audio form, it can be a video form, or it can be a simply data. So what we need to do is we need to extract the information from the modulated carrier signal. Okay, so over this diagram here, this is actually an amplitude modulated signal. Okay, so basically the signal, okay, or desired signal or the information, the modulating signal actually appear at the peak. So therefore, we just need to have a envelope and detector. Actually, basically, they just copy the peak value and we simply recover back the original signal. Okay, so basically, this in essential, okay, a demodulator actually convert the modulator signal back into its baseband form or the modulating signal, okay, so that it can be interpreted or processed further. Okay, so basically, this is what I have just explained. Okay, so keep it easy. Okay, so this is the modulator signal. When they actually pass through a envelope detector, for example, they will actually detect the peak value. Okay, as I mentioned earlier on, for amplitude modulation, okay, the modulating signal actually appear at the modulated signal. Okay, they appear at the peak, and what we need to do is basically we need to just copy the peak value, and we are able to recover back the original modulating signal. Okay, next. Okay, so I have so-called explained the down converter and also the demodulator. Okay, so let me just focus on the baseband processing part. I will explain on the channel decoder, decryption, and the source encoder. Okay, as I mentioned earlier on, we may not necessarily to convert the digital signal to the analog signal. Nowadays, in fact, most of the time, we will remain the signal as a digital signal. Okay, so let's quickly go through what is actually a channel decoder. Okay, a channel decoder is a component in a communication system that is responsible for interpreting the correct data received from a transmission channel, okay, which is typically noisy or very error prone. Okay, the primary goal is to recover back the original transmit message with the highest possible accuracy, minimize the impact of channel noise and error. Okay, so I think this will be more clear. Okay, when the data is actually sent over a channel, okay, it may acquire some error, which means that error add up to the original signal. Okay, so this can be due to noise or many internal or external disturbance. Okay, so therefore the channel encoder on the transmitter side actually add redundancy to the original data. Okay, which means that we actually add extra bit, okay, in order to counter the error. Okay, for example, using this error correcting code, okay, to facilitate error detection and also potentially correction at the receiver. Then this channel decoder actually utilize this redundancy, okay, to identify, okay, and if possible, we correct some of the error in the receiving sides. So therefore, we are able to construct back the original information as accurately as possible. Okay, so in short, okay, the channel encoder actually have some redundant bit. Okay, the key purpose why we want to have this redundant bit is basically we want to minimize the error. So for this channel decoder, is how we can remove away this redundant bit. Okay, before we actually remove away the redundant bit, we need to ensure, okay, because the extra bit, okay, that is actually on, basically help us to detect any error. So after we have done the error, okay, if there's no error, then we need to remove away the redundant bit. Okay, so basically this is what is on channel decoder. Okay, so basically in short, there are actually three main types of channel decoder: convolution decoder, block decoder, turbo and LDPC decoder. Okay, so I won't go in depth on all these different types of channel decoder. Okay, so what is the application in communication system? Okay, the channel decoder are very important in system like wireless communication, satellite communication, and data storage system. Okay, where accuracy in data transmission and storage is actually very critical. Okay, for example, for mobile network, we have Wi-Fi, okay, and the digital television here. all rely on this channel decoding to maintain the data integrity. Okay, so basically this channel decoder actually also play a role, okay, to ensure the robustness of the data. Okay, so before I continue, guys, okay, if you have learned something from this video, okay, please help by like this video. Okay, when more of you guys actually like this video will have a better chances to reach up to a larger audience. So guys, help me by press the like button now. Again, if you have learned something, okay, please help this channel by subscribe and turn on your notification bell. Let's continue. Okay, so now let's move on to decryption. Okay, what is actually decryption? We probably are very familiar about encryption. Okay, so encryption actually so-called double proof our message. Okay, so what is actually decryption? Okay, so decryption, okay, is actually very important also nowadays because any form of wireless communication, okay, we need to have some form of encryption and also decryption to recover back the original data. So therefore, decryption is very important, okay, in order to have this secure digital communication and data privacy. Okay, by ensure that only authorized party can access the decrypt data, it actually help protect sensitive information from unauthorized access or cyber threat. Okay, decryption is actually the process of converting the encrypt data or the encoder data back to its original readable form. Okay, so basically for encrypt data, we often know this as crypted text. Okay, basically they are actually transformed into the plain text. Okay, plain text is something that we understand. We are able to read it, so-called read it, okay, during the decryption. Okay, so this actually allow the authorized user to access the information. Okay, for example, we have several code. Okay, if we have this code, then we are able to do the decryption. Okay, so therefore, when we actually before transmission, okay, most of the time we will do some form of encryption. Okay, so basically when we actually do encryption, we actually move the data to, we call this ciphertext, okay, which means that this message may not make sense to anybody. But if you are the correct recipient, you have the correct so-called method to recover back the original signal. So therefore, with the correct method, okay, to recover back the original, it can be converted from this simple text to plain text. Then we successfully recover back the original message. Okay, as you can see from here, okay, so basically it's a plain text. Okay, we have some form of key protection, and we also have some algorithm, and this thing turned into something that is not recognized by anybody. Okay, so this is over here. So you can see over here, this thing actually transmit. Okay, and then let's say received by a receiver. Okay, again with a key, and then with certain algorithm, then I will be able to recover back the original message. So in short, if somebody try to so-called hijack your message, they got this form of message which is not so-called sensible to any person. The original message actually look like this, but this message probably will not have a meaningful so-called for the so-called hijacker. Okay, so therefore we need to have the encryption and also decryption in order to ensure that our data are private and secure. Okay, so come to the key point in decryption. Okay, so encryption and decryption, okay, they actually work in a pair. Okay, so decryption is the reverse process of encryption. Okay, encryption actually secure information, okay, by converting it into a unreadable data, and then we need to have a decryption to unlock it. Okay, so we most of the time, as I showed on the earlier page, okay, we actually have some form of key. Okay, most decryption process actually require a specific key or a password, okay, to unlock the encrypt data. Okay, so this key must match the one that is actually used during the encryption process, which means that when you actually encrypt, you have a key, so the identical key will be used for the decryption. Algorithm. Okay, so decryption actually relies on algorithm. Okay, for example, we have this AES 128, AES 256, etc. We also have this RSA or DES, okay, which define how data is encrypted and decrypted. Symmetric algorithm actually use the same key for both encryption and decryption. Nowadays, okay, we have this asymmetric algorithm. So basically, they actually use two form of key. One is the public key, another one is the private key. Okay, for the encryption, okay, for the public key, and for the decryption, which is a private key. Okay, where is the application for encryption and decryption? Okay, so decryption is mainly used in various applications. Okay, for example, we want to have a secure internet communication. Okay, we would like to protect our sensitive data. We need to have secure file and we need to ensure privacy. Okay, whatever form that we actually communicate nowadays online. Okay, let's come to the last portion, which is a source encoder. Okay, a source decoder, sorry, this is a source decoder, which is a component in a communication or information process system that is actually responsible for reconstructing or recovering back the original source from the encoded form. Okay, so it serves as the final step in converting an encoded message back to its original state. Okay, so in a digital communication here, data is often compressed. Okay, so if we have the zip file, for example, okay, so basically, when we actually do the zip file, the data is actually compressed or encoded to reduce transmission size, as in the case of audio, video, or text file. Okay, so the source decoder actually reverse the compressed process at the receiving end, restore the data back to its original form for the user. Okay, for instance, in audio streaming, okay, the source decoder decompress the audio signal encoded in format like MP3. Nowadays, we also have MP4, etc. Okay, so basically, this allowed them to be here as intent later on. Okay, so what is the information theory? Okay, in the context of Shannon information theory, okay, the source encoding actually reduce the redundancy, while source decoding actually reconstruct the original message, which is aimed to closely match the message that we actually send. A source decoder basically minimizes the data distortion and the losses that is actually introduced during source encoding, okay, which may employ algorithms that trade off some data fidelity for more efficient compression. Okay, for example here, okay, so in an image transmission system, okay, an image might be encoded into JPEG format, okay, so as to reduce the file size, okay, allow it to be able to send over a network efficiently. Okay, so therefore the source decoder will decode this JPEG format back into the original pixel data. Hence, this allow the picture to be able to recover. Okay, so basically you can see that it actually allowed to be displayed as the original image. Okay, so hopefully you have a better idea what is source encoder and source decoder now. Okay, so this will be my last slide for this video here. Okay, so basically the digital transceiver you can see in this diagram here mainly have the transmission section or the receiver section here. Okay, actually there is only most of the time only one antenna and we actually have a duplexer. Okay, so imagine duplexer act like a switch. Okay, which means that let's say if we want to receive the data, okay, then the duplexer will switch to the receiver side, then we will receive the data. When we actually want to transmit the data, duplexer will switch it to the transmitter and the data will be able to send out. So basically, the key purpose of the duplexer is to isolate one segment from another. As I told you that either transmitter or receiver, either one, cannot be both. Okay, basically they are all connected at a single point, okay, which is over here, which only allow for bi-direction, okay, bi-direction, which means that one-way communication, okay, to take place along a single channel, okay, without the need for additional connection. Okay, so basically with this, I hope you have a better idea, okay, what is actually a digital transceiver. Okay, so this video, I actually focus on the receiving end of the digital transceiver. Okay, with this, thank you so much, guys. I hope to see you guys soon. Bye for now. Thank you.